Hello everyone, very good evening one and all. Welcome to the most comprehensive preparation app for all exams, BYJU'S Exam Prep. And warm welcome to GATE AIMER'S 2023 series for every CSE aspirant. Join the session quickly and mark your presence. I am Satya, waiting for you all to join the session to discuss very important concept of computer networks, that is CRC and Hamming code. So today's topic is CRC and Hamming code. So guys, everybody please join the session quickly. Let us wait for a couple of minutes for all to join, and those who have joined, please mark your presence. Let me know who have joined. Also, please do like the session, share and subscribe to our BEP channel. This is my quick brief introduction. I am Satya with all these credentials. Our GATE AIMER'S series started in the November month and running successfully, discussing all important subjects, important concepts. So do attend all the classes regularly and get the most benefit out of it. And for electrical, electronics and instrumentation students, we have already started PYQ series on 18th December, and for computer science students, soon we will start this series, guys, don't worry. So attend this PYQ series where last 5 years questions will be solved live. And guys, now you can get up to 90% scholarship on all our preparation programs by taking the scholarship test. When on 24th December the scholarship test would happen at 8 p.m. So hurry up, register for this scholarship test and get up to 90% scholarship on all our preparation programs. Now, moving on to the topic. Whenever we say CRC Hamming code, firstly, we just need to recall once about data link layer functionalities. We know that data link layer, which is layer 2, is responsible for node to node delivery, framing, error control, flow control, access control and physical addressing. These are what various functionalities data link layer is supposed to perform, right? In these, let us pick this error control functionality for today, because our topic is related to this. Error, when we say error, in simpler sense, when the transmitted data or the transmitted packet is not equal to, not same as received packet, then you can say error is present. We have two types of errors, every one of us know: single bit error, burst error. So when the transmitted and received content differ by only 1 bit, you can call it as single bit error. More than 1 bit, you can call it as burst error. To handle these errors, we have two types of techniques or codes: error detection codes and detection and correction codes. What are detection codes? VRC, vertical redundancy check; LRC, longitudinal redundancy check; CRC, cyclic redundancy check; and checksum. These are the detection codes. Detection and correction code is Hamming code. What is the difference between detection code and correction code, dear friends? Detection code will find only presence of an error, whether error is present or not, whether error exists in the received packet or not. That is what error detection code says. But it cannot find which bit is error or how many bits are errors. Its job is only to find presence, error exists or not. Correction code can find both presence as well as position. Means it will tell you whether error is there or not. If error exists, what bit, at what position the error is. When you know the position in binary, correction is simple, dear friends. When you know that existing 1 is error, what should be the actual one? 0. 0 error means actual one should be 1. So correction would be simple. But the challenge is finding in that stream of bits, which bit is that error or what bits are errors, right? Our Hamming code will do that single bit error correction. Single bit error correction we will be discussing with respect to Hamming code. Okay. Firstly, we look at CRC. CRC, cyclic redundancy check, which is a complex algorithm which is based on the division process, which is derived. This CRC is derived from checksum procedure by using this modulo algorithm as the basis of operation. Means, in the simpler sense, let me tell you, we perform XOR operation. We will repeatedly do XOR operation. It is based on the value of polynomial coefficients in binary format for performing the calculations. What it says is, it is basically based on the division process. How do you get the dividend? We know that in the division process, we have 4 different terms: dividend, divisor, remainder, quotient. Isn't it? Here we are least bothered about quotient in CRC procedure. How do you get dividend? For the data word, we append n-1 zeros. Then dividend will form. What is this n? N is number of bits in the divisor. Number of bits in the divisor. Okay, that is how we get the dividend, and a divisor will be given to us, predefined standard divisors we use, and the condition is sender and receiver, source, destination, both should use the same divisor. That is the condition. Okay. Now, divisor is always given to us in polynomial form. In polynomial representation, divisor is always specified. Sir, what is polynomial representation? For example, the divisor function g of x, let's say, is given as x cube plus x plus 1. We will be given the divisor in this way. So, how we get the binary value? Mark the coefficients of x terms. Mark the coefficients of x terms. So, they are 1, 0, 1, 1. So g of x, when given as x cube plus x plus 1, the binary form of that divisor is 1, 0, 1, 1. So, it is having 4 bits. In this case, we append 3 zeros at the data word, so that added with zeros you will get the dividend. This is for the sender. Receiver need not to add any zeros. Receiver directly take the received content as the dividend, perform the procedure. Finally, he should get 0 reminder. Okay, so we will see that with example. So at the sender side, the first step is to add the number of zeros to the data, calculated using k minus 1, where k is the bits obtained through polynomial equation in the divisor. Applying the modulo binary division, that means by applying repetitive XOR to the dividend. And the last step is to append remainder to the end of the data bit. So those zeros we replace with the resultant remainder and share with the receiver. Now what receiver do? To check the error presence, perform the division again with the same divisor so that he should get the remainder 0. If the remainder is 0, the data bit received is correct without any errors. If the remainder is not 0, that says the received data is corrupted. So discard and ask for retransmission. Simple. Right. So let us see one example for this. Before that, it's a pictorial illustration. So to the data bit, the sender will be adding zeros and then do XOR with the divisor so that he will get that remainder. That remainder replaces these zeros. So that is what code word formed by the sender. On that code word, receiver apply again the same division process using the same divisor. He should get zeros back. He should get zeros back. So if he gets 0, then no error, otherwise error. Okay. Let's see one example, guys. Suppose the sender wants to transmit this using the divisor x cube plus 1. Then what is the code word? Code word is always what? Data word with redundant bits, means what is sent, that is code word. Let us find out. 1011011101 is what given data word. Divisor is given in polynomial form. Convert this into binary. 1 into x cube plus 0 into x square plus 0 into x power 1 plus 1 into x power 0. This will give you 1001 as the divisor. Right? Those who are watching it, please keep responding, guys. Make the session interactive. So this is what the divisor. As it is having 4 bits, append 3 zeros. 3 zeros. Now perform division. How? Repetitive XOR. So 1001, do XOR. Do XOR. So what do we get? From MSB position 0, 0, 1, 0. The actual algorithm shift 1 bit and borrow 1 bit, but to save the time, here you see we have 2 MSB zeros, so you just apply 2 shifts and borrow next 2 bits. Next 2 bits you borrow. 1001. When you do XOR, you got all 4 zeros. Do we have 4 bits to borrow? Yes. So apply 4 shifts and borrow 4 bits. Apply XOR again. 10, 10 we are borrowing. Apply XOR again. So this will give you 0, 0, 1, 1. Do we have 2 bits to borrow? Yes. So shift these 2 bits and borrow these 2 bits. 1001 0101. shift this bit. So when you shift this, we have got 101. There are no more bits to borrow. So here we end up. So this 101 is what we call as CRC reminder. So what is the code word? Data word 1011011101, and these three zeros we replace in this with the reminder. Reminder is 101. Right? So this is what sender will do. Receiver apply the same procedure, but he directly take code word as dividend. So 101101101101, and the same divisor has to be used. So when the receiver apply the procedure 0011, apply 2 shifts and borrow 01 here. Sorry, 0010. So 1001, he got 4 zeros and apply 4 shifts and borrow these 4 bits. 1011, 1001, when you apply, you will get 0010, and 01 you are borrowing. Then when you do XOR again, 1001, you got all 4 zeros, and when you shift this bit, you got 0 reminder. So no error. So sender first considered zeros, derived reminder. Receiver has that reminder in the code word, and he has to get back zeros. That indicates no error. Hi Tirumalai, good evening. Understood? So this is how CRC procedure is done. Now, to be able to detect all kind of errors, we have certain conditions for the divisor forming. The divisor should be divisible by x plus 1, should not be divisible by x, and the x power 0 coefficient must be 1, and there should be odd number of terms. Like this, we have certain conditions to be able to detect even number of bit errors, odd number of bit errors, right? Okay. Now, guys, at this time, 2023 aspirants, you want what? More and more practice. So to enable that practice for you, BYJU'S Exam Prep has brought test series which will give you unlimited access to full length mock tests and subject wise tests, where we have included total 4,000 plus practice questions that are having 40 plus full length mock tests and 30 plus subject wise tests, and all the questions are prepared with uttermost care, maintaining the gate level, and you will be having the virtual scientific calculator so that it gives you a feel of writing the real gate exam. Programming wala, mega mock test is enough. Yeah, you should keep attending full length mock tests and also subject wise tests till at least Jan 20th. Okay, because to improve your speed and accuracy. Okay. Now you can download our free ebook, get the notifications about our scholarship tests and also our workshops by subscribing to our BEP channel and registering through the link given in the description. Okay. Now moving on to Hamming code. This is not just detection code but also correction code, because it can find out both presence and position of an error. In Hamming code, redundant bits are not consecutive but they are placed in 2 power ith positions. The number of redundant bits that represent all states must satisfy 2 power r greater than or equal to m plus r plus 1, where r is number of redundant bits, m is data bits. Okay. 2 power r, 2 power r, this is not 2r guys, maybe it is looking like 2r for you, this is 2 power r. Okay, I have corrected it. Fine. So what is the procedure? How we form the code word? First we have to find out what are the redundant bit positions and data word positions. All the bit positions that are powers of 2 are redundant bit positions or parity bit positions. That means 1, 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4, so on. So these positions are parity bit positions. All the other bit positions are data bit positions. So we have to arrange data bits and parity bits first. Then we will calculate every parity bit, how we perform exclusive OR operation between certain position bits. For first parity bit, for position 1 parity bit, what we have to do? Check 1 bit, skip 1 bit, check 1 bit, skip 1 bit. So you have to take all alternate bit position values and perform XOR. Similarly, for position 2, 2 bits you take, then skip 2 bits, then again 2 bits you take and skip 2 bits. Similarly, for position 4, check 4 bits, skip 4 bits, check 4 bits, skip 4 bits. Position 8, check 8 bits, skip 8 bits. In that way, we have to consider certain position bits. Then we will find out by doing XOR among those bits, and we replace the resultant values in the redundant bit positions. Let us understand this with one example. Yeah, that was 2 power r only, just a typo. Okay. Suppose this is the data word. It is having how many bits? You check out, 7 bits we have. We know 2 power r must be greater than or equal to m plus r minus 1. See the formula, r plus 1, r plus 1, right? So where m is data bits, so 7 plus r plus 1 should be less than 2 power r. For what r value this satisfy? If I take r as 3, 8 greater than or equal to 11, false. So if I take r as 4, 16 greater than or equal to 12, true. So the minimum r value we have to take, so minimum 4 redundant bits are required. So now what you have to do? You have to arrange these data bits and redundant bits. Mark from 1, guys. Remember, we will mark the positions from 1. First position is redundant bit position. Let's say it is R1. Second is also redundant, R2. Third is data bit position. Fourth, redundant bit position. Fifth, 0. Sixth, 1. Seventh, 1. This is R4. Ninth, 0, 0, 1. So what is that? Check 1 bit, skip 1 bit, check 2 bits, skip 2 bits. I'll give you one simple method, guys. How many positions we totally have? 11. So mark the binary values for these 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Binary values 0, 0, 0, 1. 0 0 1 0, 0 0 1 1, 0 1 0 0, 0 1 0 1, 0 1 1 0, 0 1 1 1, 1 0 0 0, 1 0 0 1, 1 0 1 0 and 1 0 1 1. Once you mark this, what are having ones in the first position? First position is R1's position, right? So if you want to calculate R1's position, what other positions have ones in the same place? Third position, fifth, seventh, ninth, 11th. So now these position values you take and do XOR. So third position has 1, fifth has 0, seventh 1, ninth 0, 11th 1. How many ones we have? Odd number, odd number. So to make it even, let's say I follow even parity. So to make it even, R1 must be 1. How I calculate R2? R2 position is second bit position, second position. So it is having 1 in the tens place. What other have ones in the tens place? 3, 6, 7, 10, 11. So take 3, 6, 7, 10, 11. This is what? 2, 3 we have checked, skipped 4, 5, 6, 7 checked, skipped 8, 9, 10, 11 checked. This is what the meaning. Check 1 bit, skip 1 bit, check 2 bit, skip 2 bit means. So third position is having what value? 1. Sixth has 1, seventh has 1, 10th has 0, 11th has 1. So now I have 4 ones, which is even number. To make it even, R2 should be 0. Now how I calculate R3? I think now by this time you could have understood. R3 is in the fourth position. So what other has 1 in the same place? 5, 6, 7. That's it. So we have to do XOR between 5, 6 and 7. 5 has 0, 6 has 1, 7 has 1, which is even number. So to keep it even, I have to make R3 as 0. How I calculate R4? R4 has 1 in the MSB place. So what other has 1 in the same place? 9, 10, 11. So do XOR 0, 0, 1. So to make it even, R4 must be 1. So now I got these R values, right? I have got these R values. So R1 must be 1, R2 must be 0, R3 must be 0, R4 must be 1. So the code word that the sender transmit is 1001 11 00101. If 1 bit error occur, then how receiver will find out? Receiver do the same procedure, but remember, receiver consider R positions also for XOR. Okay? Receiver consider R positions also, and error always at R0, R1, R2, R3, so on at this position. So Hamming code says that 1 bit error is always at this position. So if all R's are 0, error is at 0th position. We don't have 0th position here. That's why we are numbering from 1. When all R bits are zeros for the receiver, then it says no error. If any one of the R bit receiver got as 1, that means error. Okay. So this is what Hamming code procedure. Now let's see some previous questions. This is 2005 GATE question. Consider the following message, m equal to so on. The CRC for this message using divisor polynomial x power 5 plus x power 4 plus x square plus 1 is. Let us calculate it in the binary form. It is 1 into x power 5 plus 1 into x power 4 plus 0 into x cube, 1 into x square, 0 into x power 1, 1 into x power 0. So this is the binary form of divisor, right? So form the dividend 1 0 1 0 0 1 1 0 1. As divisor is having 6 ones, append 5 zeros. Now do division procedure. 1 1 0 1 0 1, that is the divisor. So whenever we do division, how we do? Repetitive XOR 1 1 0 1 0 1. It is 0 1 1 1 0 1. Shift this one bit and borrow 1 1 0 1 0 1. 0 0 1 1 1 0. Shift these 2 bits and borrow these 2 bits. 1 1 0 1 0 1. It is 0 0 1 1 1 1. Shift these 2 bits and borrow the next 2 bits. 1 1 0 1 0 1. So 0 0 1 0 1 1. So I am doing repetitive XOR 1 1 0 1 0 1. 0 1 1 0 0 1. 1 bit I shift, borrow 1 bit. So this 1 bit I am borrowing. So this would be 1 1 0 1 0 1. This would be 0 0 0 1 1 1. So 0 0 0 1 1 1. I have only 1 bit to shift this bit and borrow this 0 here. Do XOR 1 1 0 1 0 1. It is 1 1 1 0 1 1. When MSB is 1, you can't shift. So you have to do XOR again. So it will give you 0 0 1 1 1 0. Now MSB 0, shift it out. So what you got? 0 1 1 0 as the remainder. So 0 1 1 0 is your remainder. Got it? So this is what the procedure. Using the same, do this. I am giving this 2007 GATE question for your homework. Okay, the answer should be option B. Check it out. And on the Hamming code, in 2021 we got one question. Assume that 12-bit Hamming code word consisting of 8-bit data and 4 check bits is given, arranged in this fashion. D means data bits, C means code bits, where the data bits and check bits are given in the following tables. Which one of the following choices gives the correct values of x and y? 0 0 0 1 1 0 1 1. Okay. So if you arrange these, 1 1 2 3 4 5 6 7 8 9, 10, 11 and 12. 1 is check bit, that is C1. 2 is check bit, C2. 3 is data bit, D1. 4 is check bit, C4, that is 0. 5 is D2, D4, D2, D3, D4. D4 is 0. D5, okay, 8 is C8, that is Y. 9, D5, X. 10, 0, 1, 1. Now, I got C1 as a 0. So, C1 is the XOR between 1, 3, 5, 7 and 9. 9 and 11. Right? Check 1, skip 1. Check 1, skip 1. So, C1 we got 0. That means first position is we exclude, which is okay, 0, 3 is 1, 5 is 0, 7 is 0, 9th position is X, 11th position is 1. So, if X is what, you will get it as 0. When X is equal to 0, then only you will get the code bit, the check bit as 0. So, we got X. Now, Y we want to find out. How do you get Y? Y is in the 8th position. So, for what we consider 8th position? If you look at for R4 or C8. So, C8 which is equal to Y. This is XOR of 8, 9, 10, 11 and 12. Okay. So, 8th position is what? I have Y. So, I do not know that. 9th position is what? X. X I got as the 0. 10th position 0. 11th 1. 12th 1. So, to keep it even parity, so what should be Y? Y also should be 0. So, X is 0, Y is 0. Got it, Satya? So, the right answer is X is 0, Y is 0. Right? That's all with respect to CRC and Hamming code. This is important topic, guys. Frequently we are getting bits. In 2021 only we have got 2 bits, from one from CRC, one from Hamming code. So, keep practicing so that you don't miss any marks. Okay? This is my Telegram group link. If you have not joined yet, please do join to connect with me for doubts, PDFs and to connect with your GATE aspirants, other GATE aspirants also. Thank you. Thank you so much for joining the session. I hope this session has briefed CRC Hamming code quickly. I think with this session, you became more confident with these 2 topics. See you with another topic, that is efficiency or utilization in computer networks, tomorrow sharp 9 p.m. Keep attending the sessions and please share these sessions information. This is series information to your friends who are preparing for GATE, who are unable to afford the paid courses. As this is free class, anyone can attend, right? So, try to circulate this. You can do that. You only can do that with Facebook, Telegram, WhatsApp, Instagram. Just try to share as much as possible and make these free sessions benefit as many students as possible. Okay? Thank you so much, guys. See you in the tomorrow's session sharp at 9 p.m. Till then, have a great time. Take care. Good night, everyone. Bye-bye.